When you think about harvesting fruit, you probably imagine workers carefully picking by hand. But behind the scenes, some truly bizarre machines have revolutionized orchards across America. Today, we'll explore 5 vintage fruit harvesters that most people have never seen. Ingenious contraptions that transformed how we bring fruit from branch to table. These aren't just any machines. They're the forgotten pioneers of agricultural innovation whose influence still shapes modern harvesting methods. From mechanical tree shakers to vacuum-powered pickers, these unusual harvesters tell the story of American ingenuity at its best. The tree shaker harvester might be one of the most dramatic agricultural machines ever invented. Emerging in the early 1960s, these mechanical giants fundamentally changed how certain fruits were harvested. Picture this. A massive hydraulic arm clamps onto a tree trunk and then vigorously shakes it for 5 to 15 seconds, sending ripe fruit cascading onto collection tarps below. The first commercially successful tree shakers appeared around 1962, primarily in California's almond and walnut orchards. Companies like Orchard Machinery Corporation, OMC, pioneered these systems, which could harvest in minutes what would take workers hours to collect by hand. Early models relied on hydraulic-powered piston shakers to generate vibrations, rather than spinning eccentric weights like an unbalanced washing machine. These machines were engineered to shake with just enough force to dislodge fruit without destroying the trees, at least in theory. They didn't just shake randomly. Engineers developed precise vibration frequencies tailored to different tree species. Almond trees responded best to 8 to 10 Hz, while pecan trees needed a higher frequency of 12 to 14 Hz for effective harvesting. Despite their efficiency, early tree shakers had a dark side. Some models were too aggressive, tearing bark, damaging root systems, and even breaking branches. This triggered a wave of engineering innovation in the mid to late 1960s, leading to the development of gentler shakers with padded gripping mechanisms and controlled vibration patterns to minimize tree stress. Perhaps the most interesting legacy of tree shakers wasn't just mechanical, it was botanical. As these machines became standard, horticulturists began breeding machine-friendly fruit trees with stronger root systems, easily detachable fruit, and compact growth habits that allowed for better machine access. The impact of this shift is still seen in modern orchards today. In the mid-1960s, agricultural engineers developed something straight out of a futuristic novel: the vacuum-powered apple harvester. Cornell University researchers unveiled their prototype in 1965. A bizarre-looking contraption featuring flexible vacuum tubes resembling giant elephant trunks that could literally suck apples right off the tree. These vacuum harvesters worked on a deceptively simple principle. Large pumps created negative pressure inside tubes that workers would direct toward ripe apples. When the nozzle approached within a few inches of an apple, the suction would pop it off the stem and whisk it through a padded pipe system into collection bins. The technology required precise calibration. Too little suction and the apples wouldn't detach. Too much and they'd accelerate too quickly, causing bruising. While the Cornell prototype could adjust suction power based on apple variety and ripeness, it still struggled with a major flaw. Apples often hit the collection bin with too much force, sustaining internal damage that wasn't always visible externally. This bruising significantly reduced their marketability, making the system impractical for large-scale commercial use. Field tests revealed both promise and problems. A crew using vacuum systems could harvest up to 40% faster than traditional methods, and the tubes could reach fruit in tall canopies without ladders, reducing injuries. However, the technology also had mechanical shortcomings. Sometimes entire stems and leaves were pulled into the system, clogging the tubes and jamming internal components. Engineers attempted to refine the design, but these issues, combined with bruising concerns, ultimately kept vacuum harvesting from becoming a mainstream solution. Oh, and real quick, please take a moment to hit that subscribe button. It really helps out my channel. While vacuum harvesting never became widespread, it did influence orchard management in unexpected ways. Some growers experimented with more open tree architectures to improve machine access, but this wasn't the primary driver of modern orchard design. Instead, the shift to high-density trellised orchards was mainly driven by the push for higher yields, improved pest control, and more efficient labor management. Although vacuum harvesters faded into history, their brief appearance reflected the constant search for ways to mechanize delicate fruit harvesting, a challenge that continues to this day. The 1940s and 50s brought a peculiar revolution to America's berry fields with the introduction of mechanical berry harvesters, strange contraptions that looked like something from a Dr. Seuss illustration. These machines, first developed for blueberries in New Jersey, featured massive rotating drums studded with hundreds of flexible tines that would comb through berry bushes like giant mechanical fingers, stripping fruit from the branches. Michigan State University agricultural engineer Fred Henson created one of the first commercially viable models in 1954. His berry beater used a fascinating combination of vibration and gentle stroking to remove ripe berries. The machine would straddle entire rows of bushes, its tine-covered drums spinning at precisely 120 RPM. Any faster damaged the fruit, any slower left too many berries behind. This critical speed was determined through thousands of hours of field testing across different berry varieties. What made these machines truly remarkable was their internal fruit handling system. Once berries were combed from bushes, they'd fall onto the moving canvas belt that transported them through a series of cleaning stages. First, powerful fans would blow away leaves and debris. Then, the berries would bounce across specially designed separation decks, cleverly angled platforms that allowed ripe berries to roll into collection bins, while green ones, being more angular, would catch on the surface and be returned to the field. The berry harvester's economic impact was immediate. Before mechanization, harvesting a ton of blueberries required approximately 500 labor hours. The early mechanical harvesters reduced this to just 10 to 12 hours, a staggering 98% reduction. By 1965, nearly 60% of Michigan's commercial blueberry crop was being harvested mechanically, despite the machine's substantial $8,000 price tag, equivalent to about $65,000 today. These contraptions weren't without their problems, though. The early models were notoriously indiscriminate, removing unripe berries, ripe ones, and sometimes entire branches in one pass. This led to a fascinating adaptation in berry cultivation. Growers began selecting from machine-friendly bush varieties with concentrated ripening periods and berries that detached easily when mature but held tight when green. The Berkeley blueberry variety became particularly popular specifically because it withstood mechanical harvesting better than other types. Perhaps most interestingly, these machines inadvertently changed the flavor profile of commercial berries. Handpickers naturally selected the largest, ripest specimens, leaving the less mature fruit for later harvests. Mechanical harvesters took everything at once, resulting in more variable ripeness in each batch. Processors adapted by developing new quick-freezing techniques that would halt the ripening process at different stages, maintaining the mixed character that came to define commercially harvested berries. The social implications were equally significant. While reducing backbreaking labor was positive, these machines displaced thousands of seasonal workers. In response, some innovative growers established cooperative ownership arrangements where former picking crews could collectively own and operate harvesting machines, serving multiple farms and preserving their livelihoods through technological adaptation rather than replacement. The late 1950s introduced one of the most unusual sights in American orchards: mobile harvesting platforms that resembled mechanical flying saucers hovering between fruit trees. These peculiar contraptions, first developed by the Bartlett Equipment Company in Michigan, revolutionized high canopy fruit harvesting by literally elevating workers to the fruit rather than bringing the fruit down to ground level. The original designs featured circular platforms ranging from 12 to 20 feet in diameter, mounted on hydraulic scissor lifts attached to specialized tractors. What made these machines truly innovative was their multiple independent working levels. Unlike simple cherry pickers, these platforms could simultaneously position up to 8 workers at different heights throughout the tree canopy. Each worker stood in a padded safety station equipped with fruit collection chutes that fed into a central conveyor system, delivering picked fruit to cushioned bins below. The most technologically advanced models, like the Orchard Cruise Master, introduced in 1963, incorporated pneumatic stabilization systems that maintain perfect platform balance even on hillside orchards with up to 15-degree slopes. This self-leveling capability relied on mercury switch sensors that detected tilting and automatically adjusted hydraulic pressure to each support leg, remarkably sophisticated technology for the pre-digital era. These platforms dramatically transformed harvesting economics. Traditional ladder-based picking required workers to climb up and down constantly, spending only about 40% of their time actually harvesting fruit. Platform systems increased productive picking time to nearly 80%, effectively doubling worker efficiency. Additionally, ladder-related injuries, previously the most common accident in orchards, were virtually eliminated, reducing insurance costs for growers by an average of 35%. What few people realize is how these platforms influence tree architecture itself. Horticulturists began developing platform-friendly pruning systems that created more uniform fruiting zones at specific heights that aligned with platform working levels. Washington State's Tree Research Station introduced the fruiting wall training system specifically to optimize harvesting with these platforms, a method now standard in modern high-density orchards worldwide. The platform's biggest technical challenge was maintaining stability during operation. Early models used outrigger systems with massive ground pads, but these compacted soil and damaged tree roots. Engineers eventually developed innovative flotation wheel systems with ultra-wide, low-pressure tires that distributed weight across a broader footprint, reducing ground pressure by nearly 70% compared to standard tractor tires. These machines also affected fruit quality in unexpected ways. Platform picking allowed fruit to be harvested at optimal ripeness across the entire tree simultaneously, rather than following the bottom-to-top progression of ladder picking. This resulted in more uniform maturity in each harvest batch, which processors and consumers quickly came to prefer. Some varieties of pears and apples actually showed higher sugar content and better color development when harvested using platform systems, simply because timing could be more precise. By the mid-1970s, these platforms had become standard equipment in large orchards across Washington, Michigan, and New York, with specialized versions developed for peaches, apples, pears, and even citrus. Their fundamental design principles continue to influence modern harvesting systems, making these strange, elevated workstations one of the most enduring innovations in orchard mechanization. The 1980s witnessed the birth of a technology that seemed plucked straight from science fiction: robotic fruit harvesters. These experimental machines, developed at agricultural research stations in California and Florida, represented the first serious attempt to fully automate the delicate process of fruit picking. The earliest functional prototype, nicknamed Cyclops by its creators at the University of California, Davis in 1982, featured a single mechanical arm mounted on a tracked vehicle base. Its primitive camera system could distinguish basic color patterns, giving it a rudimentary ability to identify ripe fruit. These early robotic harvesters operated on surprisingly advanced principles for their time. Cyclops used a combination of machine vision and spectral analysis to differentiate fruit from foliage. Its camera system processed images through analog color filters, allowing it to detect red apples against green leaves. Once a target was identified, additional sensors measured light reflection at specific wavelengths to estimate sugar content and ripeness before deploying the picking arm. The mechanical arms themselves were a lesson in engineering compromise. Early designs attempted to replicate human hands, but quickly proved too complex for the available computing power. Instead, engineers developed specialized end effectors for different fruits, vacuum suction cups for apples and oranges, scissor-like clippers for stone fruits, and spiral-twisted fingers for berries. Each tool included force feedback sensors that measured resistance as the fruit was grasped, preventing excessive pressure that could cause damage. In 1986, Florida's Citrus Research Institute introduced Orange One, the first robot specifically designed for citrus harvesting. Its standout feature was a navigation system that built a three-dimensional map of orchard rows. Originally believed to use sonar, it more likely relied on an early LiDAR-based system to create spatial models of each tree and calculate optimal arm trajectories, at least in theory. But theory and reality were two very different things. The biggest challenge these machines faced was speed, or lack thereof. Computing limitations meant image processing took several seconds per fruit, slowing harvesting to a crawl. The robotic arms operated with extreme caution, sometimes taking up to 15 seconds to pick a single apple, a task a human worker could complete 10 to 15 times faster. While power supply issues were a factor, the real bottleneck was processing time. Even when connected to gasoline generators or power cables, these robots simply weren't fast enough to compete with human pickers. Despite their limited success, these early robotic harvesters left a lasting mark on orchard management. To accommodate future automation, researchers began developing robot-friendly tree architectures with simpler branch structures and evenly spaced fruit. The fruiting wall concept, where trees were pruned into flat two-dimensional planes, emerged partly in response to robotic harvesting. Similarly, fruit varieties were evaluated for machine visibility. Factors like contrast between fruit and foliage, fruit clustering patterns, and stem attachment strength. While these early robots never replaced human labor, they paved the way for the sophisticated machine vision and automation used in modern agriculture today.